Pourtsidou is Professor of Theoretical Astrophysics at the University of Edinburgh. She's at the European Space Operations Centre in Darmstadt in Germany and has been telling me about the mission's main purpose.
This mission's main purpose is to basically give us the best map of the universe, the largest and best three-dimensional map of the universe ever made. Three-dimensional means we are looking both across the sky and a long time. So it's going to look back 10 billion years from today, and it's going to cover 1/3 of the sky. That's a huge part of the volume and history of our universe.
That's the most extraordinary answer I think I've ever heard in my life. Just how significant is today in your career and in the story of modern science?
It is extremely significant because we are really, this era, we call it the golden era of cosmology. And that is because in the last few years, I would say in the last 20 years or so, cosmology is really a precision science, and it's a big data science. So we have very vast quantities of data, of very high quality data, that really allow us to take these pictures of the universe, construct these maps, and also we have the techniques and the theoretical models, mathematical models, and computer codes to really extract the maximum amount of information from them. So I think it's the best time to be a cosmologist and an astrophysicist today.
What might you discover that we didn't know before?
So maybe you and your audience have heard that a big part of the matter and energy budget of our universe is dark. We have these two components that are very exotic. We don't really know what they are. Fundamentally, we know what they do. These are dark matter and dark energy. And you can think about Euclid as an experiment that is about 10 times better than what we had until now. And this means it can tell us 10 times better what dark energy and dark matter might be, because it will really pin down what dark matter does in the largest scales of the universe, and it will really pin down how dark energy evolves, if it evolves, a long time. And this is what we really, really need to find clues on what this exotic matter and energy might be.
Will these be quick results, Professor, or is it going to take a long time to interpret all of this new data?
That is a fantastic question. I think it's the best question I've ever heard. It's going to take a long time because we are doing precision science, and that depends on many things. The nominal survey is going to last six and a half years. So the final data release is going to be ready only then. Of course, we will have, even from the first year, we will have beautiful maps and we will be able to do a lot of science. But really, the final data set, the one that will be, the best map ever delivered, it will be 6 years after. But it's not only that. We are facing big data challenges, simulations challenges, even theoretical challenges. We have to find good enough models, mathematical models, to fit this amazing data that we have. So I think it's going to take a few years. I'm super, super excited for the next 10, 15 years that I think it's going to take to really have the first groundbreaking results for physics.